My name is Roger, and I built this color sorting machine as a part of a guest lesson for a group of 10-year-old primary school students. The goal was to inspire them with technology by showing how sensors, motors and a bit of programming can come together to solve a real-world task, like sorting candy by color. Of course, the kids quickly pointed out that they could just sort the candy by hand much faster. But that didn't stop them from being fascinated by how it all worked. I designed and 3D printed mechanical parts myself and used an Arduino with a color sensor and servos to bring the machine to life. In this part I will walk you through the 3D design and explain how the different components fit and move together. Let me show you the design of the different components for the Skittler sorter. Let me first turn off all the other components so they can focus on one component first, and that's the buffer. The buffer's goal is to feed the Skittles one by one into the machine. This is done by filling this large buffer up with 1 or 2 bags of Skittles, and the sweeper inside this arm will turn around and will feed to this one hole all the Skittles. The sweeper changes directions now and then. The reason is sometimes 2 Skittles can block the entrance. By changing the direction of the sweeper, this is prevented. The sweeper itself is connected to a shaft to a large gear, and this gear is driven by the 360 servo, which we will show you later on in the design. Let's have a look to the next component, called sorting disc. The sorting disc's main function is to move the Skittles to the right spot. In the first location, the Skittle is collected, a new Skittle is collected, brought to this location where it will be color censored, which I'll show you later, and then transported to one of the exit gates to be dropped. The moving disc, the black one, is, let me turn off the buffer, show you, the moving disc is the one that turns and it's connected to the shaft of a Nemo 17 stepper motor. Using this microsensor, we can detect if a hole is at the right location. The servos, which are connected to a bigger part, is called the fixed disc. The fixed disc is a big part where the motor, the step motor, is connected to using M3.5 screws, and also the servos are connected with those same screws, M3.5. For the servos itself, I designed a trapdoor which is connected to the servo directly, using the normal components supplied with the servo. Back to the fixed disc. Let me turn it on again. The fixed disc itself rests on the base, which we show later, with these holes. So the fixed disc just leans on the base. It's not screwed down or glued down for easy access later when you want to change something. When I was building this design, I had a problem with the cables running from the servos, and a trick I did was to glue the cables to the bottom here, the bottom of the fixed disc, and collect all the cables in the middle. Maybe in a redesign we can make some kind of cable spaces in there. The next component to have a look at is the color sensor. The color sensor itself, like the component itself, is fairly straightforward. Let me just turn off the sorting disc and the buffer, and the color sensor itself has a cap, and the sensor, of course, which is a board component, external component, and the sensor bay. The sensor bay is not more than just a placeholder for the sensor with a large hole for the cabling. The sensor is screwed on top, and the sensor cap sees to it that there is no lighting coming in from the environment. In the final design, I didn't print it in white, but I printed it in black PLA to make sure that the environment lights really kept out. If you look to the sorting disc, if I put it back and look at the sensor, and just turn off the cap and the sensor bay, you will see that the sensor is located a few millimeters above the Skittle itself for good color detection. The base is the part that's rests on the table and that collects all the sorted Skittles. If I just turn off the other components, just to have a look. The base itself consists out of multiple tubes where the Skittles fall down, the sorted Skittles fall down and are collected. You can also see that the base has some kind of pillars and the sorting disc just lays on those pillars. Also, this base holds down the servo, the 360 servo, with the gear that drives the buffer. So the servo driving the buffer is located in the base. The electronic bay is the last component we didn't cover yet. All the electronics should go somewhere. For this I designed electronic bay. It's a simple piece of 3D design which can bolt down all the components needed, like the 12-volt 3.5-volt converter, the step motor driver, the servo driver and of course the Arduino itself. It's a simple part with all the 3.5mm holes prepared for bolting down the components. Originally I designed to use screws to fix this electronic bay to the base, but during the build I couldn't reach it with a screwdriver, so I've used glue to just glue it in. A new design, a next revision maybe, I need to think something else for that. In this overview I show all the components I used for this project, which are all easily found on the internet and are not expensive. One thing I forgot to show is the horizontal bearing for the sorting disc. I will also supply a complete list of the components used in the project description. The Arduino program is like 3D design, one of the first versions, so there's a lot of room for improvement. This program will be added in the project files. Let me go through it shortly. Of course, in the beginning all the definitions, but I only will highlight the special things, the things that looks a little bit different maybe. This part I configure the min and max values, making sure that the servo doesn't hit the sorting disc and opens far enough for the candy to fall down. In the main loop you can see there are a lot of steps, like the button that triggers the starting or stopping of the machine, but I think the special part I want to highlight is the serial commands. I've added this for ease to debug the system, but also to calibrate the colors. So serial commands can be given, like the test, which will run the servos and the disk for, several times. Validate is a separate program. Using this, the disk will sort and will position each item 25 times before the color sensor, making it easier to check the color configuration. Why is it important? I will go down to the program at the end. The sensor we are using gives back 3 different values. For red, green and blue. And the combination of these 3 values will give you a certain color. But it can vary. So for example, for red, the blue value, the blue filter is somewhere between 25 and 28. And the yellow, it's 17 to 20. To find the correct values, I'm using the validation routine. I will show you how it works. thank you for watching this till the end and thus showing interest in this design. I've made this especially for an elementary school to be able to give a lecture about how cool technology can be. My time for designing and programming was limited. I do realize there's a lot of room for improvement for the 3D design and also the code. Hopefully you can take it even further